Okay, this is 13.1. We're going to talk about a couple different formulas and things. The first thing I'd like you to do is you can see I have a coordinate plane here and I identified point A and B. What I'd like you to do is push pause and use your own thoughts on how to find the distance between A and B. Okay, this is kind of like what we did in class. I'm trying to get you through the exploration of it, but how would you find the distance between A and B? So push pause now and try to figure that out. All right. What a lot of people did in class was they drew out a right triangle and counted how many blocks, then used the Pythagorean theorem to find the length of AB, and that would be the square root of 13. So let's look at what we did there. And then we said, you notice I took the graph paper part off and said, let's generalize this. How would you have done it before? So again, you just saw what we did there. I'd like you to push pause and really try to figure out how would I generalize it if D represents distance and these are the variables that represent the coordinates of the 2 points. So push pause now and give that a try. All right. Again, if you look at finding the differences from one point to the other, it's the difference in the y coordinates, difference in the x, and some of you again have seen this before when we did slope. So using the Pythagorean theorem, d squared, which is the distance between these 2 points, equals this difference squared plus this difference squared. So to get the distance, I can do the square root of the sum of those squares. So this is the distance formula. It's something, you don't need to memorize it. It is basically using this idea of the right triangle. All right, so you can try these. Find the distance between these points if you want to kind of sketch, or if you would like to use the distance formula, do what works for you, and then come back and check. All right. So here I have the change in x. So it went from 2 to 8. That's my horizontal distance. From 5 to 5, it didn't go up at all. So a lot of you may not have even needed the distance formula for this. You may have kind of been able to see how far that would be. And these are the answers for the remaining ones with work shown. So check over those. If you have any questions, just write that down on your notes so that you can come and ask me about that and I can check your work for you. Push pause if you need to be on the screen a little longer. All right, so the next thing is we have a circle. And, excuse me, I move that out of the way. Has a center at 5, 6 and a radius of 4, and find the equation of the circle. We did this in class, but for video purposes, basically what we did is we looked at that distance formula again and said, I know the distance now. The distance is 4, and I don't know this one at this point, but I do know this one. And remember, the distance will be 4 between this point and this point over here on the circle, or this circle. That's what a circle is. It's a bunch of points that are the same distance from a center or one point. So we don't really like that. So we're going to square both sides. That's how we got to this bottom answer here for the equation of a circle. And if you take this and plug it into Desmos, if you'll take a moment and open Desmos, if we plug that in, you'll see, look, 5, 6, there's the center of the circle, and the radius was 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. So Desmos will also show you that that gives you a circle. So now you know how to create circles. And again, go back here, look at where the 5 and 6, that was the center point. Look at where they ended up over here. And here's the radius. Where did that show up, and how did it show up in the final equation? So again, we're going to go and try and generalize that. Again, I did it for video purposes. I took this, and basically I said, okay, well, last time, this was my equation before. This is actually it right here. So the 16 was the radius squared, so that's what that'll be. And it was x minus this x coordinate of the center plus y minus the y coordinate of the center. And I know I'm going through this quickly. In class, we did a lot of discovery with this, a lot of discussion. But again, for the video, I'm making it a little faster. But please kind of look at the meaning. And basically what that's saying is I'm solving any x and y that I plug in, a combination that makes this true, means that the point I'm plugging in is 4 away from here, and therefore it would be on the circle. All of these, there's an infinite amount of solutions to that. So given your formula now, r squared, right back here, this is called standard form of a circle. There it is. You want to make sure you note that. Use that and this information. The first part, you're going to use this information and write an equation. And in the second part, you're going to given the equation, give me some information you can get from that. So please push pause now and try that. All right, what you'll see here is I did the radius squared. So notice it's 25 and not 5, because that was the r squared equals x minus the x-coordinate of the center, so that's going to be 4, y minus a negative 3. That's why it's a plus 3 over there. And again, remember in the standard form, the radius is being squared. That's very important. And then it's x minus the x-coordinate, so x minus a negative 1 makes it a plus 1, y minus a negative 2 makes it a plus 2. And that's the equation. You don't need to multiply this out or anything. Now going backwards, okay, it's x minus the x-coordinate. So what's being subtracted from x? 8. Okay, what's being subtracted from y? 1. So the center is 8 comma 1, and the radius, remember this is the radius squared, so to get the radius you square root that, that'll give you 8. And over here the same idea. I know this is a plus, that gets a little confusing. Wait, what am I supposed to do? What would be subtracted from x to get plus 9? A negative 9. And again, the 5's coming from the square root of 25. For the next couple of problems, I'd like you really just to come up with a plan before you try and look at this. Even if you don't solve it all the way, I want you to come up, how would you approach this problem? What would you do? So push pause, give it a try, and then come back. All right, so if I'm looking at a triangle that's isosceles, I know I need to show that there are two sides congruent. So what I did here is I found the distance between each set of vertices. And when I did that, I found that AM and AY are congruent, so the triangle is isosceles. I proved two sides are congruent. For the next problem, I have to write an equation of a circle. So it's got to be that r squared equals x minus a squared plus y minus b squared. So I know the center, but I don't know that radius. So to find the radius, the first thing I'm going to do is find the distance from the center to the point on the circle. That makes sense. That's what a radius is. So I found the distance, and that makes the radius 10. Okay, and now I'm going to plug that into the formula. You're not going to use the 6 and 14. That's only 1 point on the circle. So we're not going to use that. We just use that to figure out the what the radius was. So x and y need to be in your equation because our equation should be something so that we could find all the points. So there's a lot of variation there. X minus the x-coordinate, y minus the y-coordinate equals the radius squared. That's why it's 100. Okay, so check Canvas for your homeworks, and we are going to get into more circle stuff on the next day.